Hello, everyone, and welcome. I'm Christy Harner, the Vice President of Marketing here at ZwitterCo, and I'm excited to welcome you to today's session on ZwitterCo's Elevation Membranes. Thank you so much for taking the time to join us. Before we begin, please note that we will have a Q&A at the end of our session, answering questions from the audience. To ask a question, please use the icon at the bottom of your Zoom screen to send us a message, and I will be collecting those throughout the webinar and asking our experts on the team to answer as many as we can before our time runs out. If we don't answer your question live this hour, don't worry. We will be sending you a personal email following the webinar to give you a detailed answer on your questions. For those who may just be hearing about ZwitterCo, let me quickly introduce you to our company. ZwitterCo is a global leader in membrane solutions for challenging separations. We help industries treat complex wastewaters, purify water for reuse, and maximize efficiency in food processing applications. Our company leverages its breakthrough Zwitterionic chemistry to build membranes with unprecedented fouling resistance, overcoming the longest standing limitation with traditional filtration. As you can see from our screen, and you can see some of our partners listed, we are already working on many exciting new projects around the world, and we're excited to expand our network to people like you. And I hope you get a lot of insights and ideas from this webinar. Okay, let's get started. Joining me today are three of my colleagues who will be sharing their various expertise with you. First up, we will have Chris Drover, our Chief Technology Officer, who will be walking us through a deep dive on our ZwitterShield technology. Next up will be Umang Yagnik, our Senior Channel Growth Manager, to share about our Elevation product family and dive into performance data. And then Andrew Hunt, our Applications Engineering Manager, who is going to share real-world studies and give you a sneak peek at our new features we'll be releasing. And now, without further ado, let me hand it over to Chris.
Thanks, Chrissy, for that introduction. I'm excited to be here today to talk with all of you about advancements in our technology and updates that we've made to our product line. We've got a lot of interesting material to cover, but I think it makes sense to start from the beginning in a sense. I think many of you know us, but if you're new to ZwitterCo, first of all, welcome and thank you for coming. Our primary focus is developing membrane technology to address organic fouling. And so one might ask, what is organic fouling? And it's essentially what you see in the pictures on the screen. This is a process by which organic material that's dissolved or suspended in wastewater will reduce the performance of a filtration membrane. And in many cases, this can be irreversible. We see organic fouling as one of the sort of largest limiting factors in the broader adoption of membranes in applications like water reuse and wastewater treatment, and even some food and processing industries. Fouling increases costs and sort of limits the different use cases where membranes can be deployed without extensive upstream pretreatment to reduce the organic burden. So how does ZwitterCo fit in? Starting from an early foundation of university research, we've developed a chemistry platform that leverages the power of Zwitterions to build membranes with breakthrough performance in the face of organic fouling. What are these Zwitterions? Well, Zwitterions are a unique class of chemical, really a chemical compound that contain both positive and negative charges within the same molecule, usually in very close proximity. This gives these molecules really interesting properties. Because they contain these cationic and anionic groups, they interact with water much in the manner of a salt or an electrolyte. And so they're a really, really hydrophilic compound. On the other hand, they are organic molecules. And so that means that we can use our full toolkit of organic synthesis, polymer chemistry, and material science to use these chemical building blocks and build new functional materials that we can then eventually adapt into really high performance membranes. We're continuing to develop this technology and release a wider variety of membrane products with different selectivity and different form factors to serve the different needs of everything from wastewater treatment, water reuse, and as I mentioned, some food and beverage processing applications as well. One of the things that we get really excited about, and that our team tells me all the time, is it's really interesting to get to work with the process of bringing a new material or a new class of materials to market. For a lot of years, the debate in the membrane world has kind of been between polymeric membranes on one hand and ceramic membranes on the other. And while each of them has their advantages and different areas where they shine, one of the things I find interesting about that is that in both cases, those are membranes that are made from materials that were already out in the market long before they became membranes. So the different plastics that we make polymeric membranes out of, things like polysulfone, PVDF, and polyamide, were in mass production for other uses long before they became membranes. And the same is true for the different types of minerals, titania and others that are used in ceramic membranes. What the introduction of these Zwitterionic copolymers and some other materials like that is really bringing us into a new era where we're designing materials from the beginning with the explicit goal of turning them into high performance membranes. And this is a really big paradigm shift in how you approach the technology and you approach the technology performance. When you're starting from the beginning with sort of selecting the atoms and selecting the functional groups that you need in that material, you can unlock some pretty incredible properties and capabilities. One of those, and you'll see this in the video that's playing on the screen, is that the attraction between zwitterions and water is so strong that these materials almost form a hydration layer or shell. And this water layer is really tightly bound to the zwitterionic chemistry, and it effectively prevents oil and grease and other foulants or proteins from contacting or sticking to the surface. Another really interesting feature of the Zwitterionic chemistry that we've built is that it's so permeable to water as a material that we don't need to have membranes that are porous in the classical sense of having little holes and openings. And this is a really big benefit because those holes and openings are really one of the fouling sites where once foulants get into the pore structure, it's very, very hard to remove them. So this is a very big difference for these type of materials. Finally, the Zwitterionic chemistry we use is overall charge neutral and has a bunch of other chemical properties. And we've engineered it so that's true over the entire operational pH and temperature range. So the membranes don't depend on a particular set of conditions to have their hydrophilic and anti-fouling properties. So as I said before, our goal is really to develop this chemistry as a platform for advanced membranes. To that end, we've developed two different membrane technologies that serve a couple different use cases. ZwitterCore is our term for what some might consider the original ZwitterCo technology that we started to bring to market over the last 5 years. These are fundamentally new membranes where all of the membrane properties, everything from the permeability and the selectivity to the fouling resistance, is coming from that Zwitterionic chemistry. Really, the Zwitterionic material is the membrane. That's what's doing the membrane job. More recently, and this stands in a little bit of contrast to our ZwitterShield technology. This is a variation of this chemistry that we've developed over the last couple of years and a new manufacturing process that we use to add this protective layer that guards against organic fouling to existing membranes in a way that's permanent and doesn't compromise their intrinsic membrane performance. And this technology is what powers our Elevation RO membranes, and it's what we're going to spend a little bit of time on today. So what is ZwitterShield? The story of ZwitterShield starts with a lot of conversations that we had with customers. Folks would come to us and say, I've got a site and it's struggling with organic fouling, maybe having high cleaning costs or short membrane life, but the justification wasn't really there to deploy a bunch of new CapEx and put in new unit operations and put in a new membrane system. They were just looking for maybe an opportunity to retrofit those existing membranes with something better suited to managing that challenging water quality. We realized that with the chemistry we've developed, we had what we needed to engineer a new version of the technology that leverages the Zwitterionic materials to improve the performance of a conventional membrane. We developed ZwitterShield for these use cases. ZwitterShield is a permanent Zwitterionic protective chemistry that's bonded to a normal membrane and dramatically improves its resistance to organic fouling. The products using this technology in general have the highest allowable limits for membranes in their class against things like total organic carbon, chemical oxygen demand, oil and grease, and other organic components. These membranes also have faster, better cleaning outcomes, and they use fewer chemicals and cheaper chemicals to do those cleaning operations. ZwitterShield makes a huge difference in applications like surface water, wastewater, and process effluent, where conventional membranes generally work, but they're taking a big performance hit or spending a lot of extra operating costs due to organic fouling. Our initial focus for ZwitterShield has been on brackish water RO. And this made a lot of sense for us because brackish water RO is one of the core building blocks of wastewater reuse, surface water treatment, and these other use cases where organic fouling is a really big concern. With ZwitterShield, we can enhance brackish water RO by providing a dramatic reduction in the surface roughness, a huge increase in the hydrophilic character of that surface, and effectively a UF class barrier that prevents larger organics and colloids from ever contacting the polyamide membrane underneath. Put together, these features provide a step change in performance for brackish RO systems that are struggling with organic fouling. And I want to share a little bit more about these different attributes and go over some of the scientific data that illustrates why it works and show why this technology is so powerful. So I mentioned before, and it would be easy enough to just say that the surface is smoother, but I think seeing is believing. So I wanted to start by sharing this with you. What you're looking at on the screen is scanning electron microscopy. On the left, you see what you might consider a standard brackish RO membrane. And for anyone that's looked at an electron microscopy of a brackish RO membrane before, the image on the left should be pretty familiar. These products tend to be pretty rough on their surface. This is at the microscopic level, of course, but that's a result of the interfacial polymerization process by which they're made. On the right, you see the same type of membrane from the same lot, but it's been upgraded with ZwitterShield, and it now has this really smooth surface facing the incoming feed water. In raw numbers, this basically is a reduction of the surface roughness from about 50 to 100 nanometers root mean square down to less than 10. This is a huge step change in the surface roughness, and it reduces the surface area and the sort of little anchoring sites where organics and other compounds can get stuck and be hard to remove. Now, remember, even though we're adding material on top of the existing RO membrane, this material is 20 to 40 times more water permeable than a conventional RO polyamide membrane. And so it doesn't meaningfully impact any of the core performance like the operating pressure or the salt selectivity or any of the things that that RO membrane is supposed to be doing. It's merely protecting it against the organic contaminants. We also talked earlier about the surface being really hydrophilic, and this means water loving. So one of the classic measurements you use to look at this is called contact angle. And if you're unfamiliar with it, I'll kind of explain what's going on here. What you're looking at on the screen is a inverted membrane with, at the top of a water-filled cell with a really high zoom image of a tiny air bubble up against that membrane. When we say contact angle, what we're talking about is the angle that's formed between the three-way interface between the membrane, the water, and the air. And so down below, you can see we've got some contrast enhanced images. We're calling out that angle. But if you focus your attention above, you'll notice on the left, this air bubble, the air is kind of grabbing a lot of real estate here, right at the interface. The air membrane contact area is fairly large, and it's pushed the water out to the sides, and that's why it's forming this kind of steep angle at the edge of the bubble. You contrast that with the image on the right with the membrane that has ZwitterShield. Notice that the air contact area is quite a bit smaller, and the water has actually pinched in pretty far, trying to maintain as much surface contact with the membrane as it can. And this is due to that really hydrophilic surface. Again, coming back to numbers, typical RO membranes might have a contact angle of 40 to 50 degrees. This can vary a little bit because there are surface treatments that are sometimes used to improve this, but they tend not to be permanent. And so after a few months or years, a couple cleaning cycles, they would revert back to something like this. The ZwitterShield material has a contact angle of 20 degrees or less, and that is a permanent new top surface of the membrane that will not wear off over time. So even after a long time of use, you're still going to have this hydrophilic surface. So all of this rolls up into a really extraordinary difference in fouling rate and difference in cleaning outcomes. We're going to start looking at some lab data, and I'll be the first to say lab data, is lab data, and we're going to look at some real field data later to see how this plays out in the real world. But the great thing about lab data is you can kind of isolate the variables. You're holding constant temperature, you're holding constant feed quality, things you don't always get to do at a real plant. And so you can really start to see just the intrinsic differences. What we have here is two membranes in the lab, one with ZwitterShield, one without, that are treating a very aggressive, sort of, unrealistically contaminated stream, but it lets us get this experiment done in about a week and highlight the difference. You've got some protein and some natural organic matter. We start both membranes They're both calibrated to start at the exact same flux, so we adjust the pressure to accommodate any slight differences in the coupons, and then we let them run. And you can see that the fouling rate in the standard RO membrane is double what it is in the ZwitterShield membrane. And that continues throughout the course of the experiment. So even 6 or 7 days in, when the standard membrane is running at a considerably lower flux, it's still declining at a higher rate than the membrane with the ZwitterShield. This is, basically, then you translate this to the real world. This is how you're able to manifest things like a less frequent CIP schedule, lower operating pressure, and the other operational improvements that Umang is going to share with you later on. So we'll turn our attention now from the laboratory and scientific data to the product lines and sort of what we have to offer using these technologies. You may have seen over the last few weeks to months, we've really updated and clarified our product lineup to give customers a better understanding of, for their particular use case, what's the right membrane for them. And we've introduced our Expedition, Evolution, and Elevation product families for these different needs. The Expedition membranes are based on the Zwitter core technology that we discussed earlier. And these are really meant for extreme conditions. These are some of our most rugged membranes, and you can think of them as being both a really high performance membrane and a fairly customized membrane process to deal with those extreme conditions. We're not going to talk too much about this today, but if you're interested in these kind of use cases, we have an upcoming webinar that'll cover them in detail. Our Evolution membranes are food-grade process membranes designed for the specific needs of dairy and food processors. These are made out of materials that are compliant with food contact, and they are designed to be used in those existing membrane systems that are out in service in the world right now in food and process applications. They use both ZwitterShield and ZwitterCore in the various different membrane products in that lineup. And finally, the focus of our webinar today is the Elevation membranes powered by the ZwitterShield technology we've been talking about for the last couple of minutes. These have outstanding resistance to organic fouling, and the real key to understand is that they're designed to fit seamlessly within existing membrane systems or in new membrane systems that are built using conventional membrane process design, so nothing special. And the team's going to talk a little bit more about that to help illustrate how these can be a really nice replacement for the more common types of RO membranes you see on the market. So with that, I'm going to turn the floor over to my colleague Umang, who's going to talk through the Elevation product lineup, as well as some of the nuances of the different use cases and how to get the most value out of them.
Thank you, Chris. I'm very excited to be joined by two very knowledgeable colleagues today for this webinar. Well, Chris, you helped us dive into the features and benefits around the ZwitterShield technology platform by ZwitterCo. Let us take a quick look at the RO membranes that are commercially available with the ZwitterShield technology. As mentioned earlier, we announced 3 product brands this month, one of which is Elevation. So ZwitterCo, under the Elevation brand, offers 3 different categories of RO membranes. Essentially one membrane type, which is a brackish water RO membrane that Chris alluded to earlier, but 3 different types of membranes, meaning first of which is a high rejection brackish water RO membrane. Second is a low energy brackish water RO membrane, both of which are NSF certified. And the third one is a high pressure RO membrane. This is basically an Elevation high rejection membrane flat sheet rolled in a high pressure configuration so that it can handle up to 1200 psi or 83 bar feed pressure. This specific membrane finds application in, for example, first pass RO in a landfill leachate application. And it is also offered in a 50 mil feed spacer along with the industry standard 34 mil feed spacer. Now, all these membranes are offered in a standard 8-inch and 4-inch configurations, some of which are also offered in a 2540 configuration for pilot scale systems. Now, of course, let's take a quick look at the specifications of these RO membranes. For high rejection RO membranes, we're looking at a 400 square feet membrane area packed in a 8040 element with 34 mil feed spacer, which makes it very easy to replace most conventional RO membrane elements in an existing system. Now, with comparable salt rejection, these membranes offer optimal permeate quality while offering the benefits of ZwitterShield technology. And the specifications of high pressure RO membranes are quite similar to that of Elevation high rejection membranes, except for the fact that they can handle up to 1200 psi or 83 bar feed pressure. For low energy RO membranes, again, we're offering 400 square feet membrane area with 34 mil feet spacer in an 80/40 element, making it easy for one-to-one replacement in low feed TDS RO systems that are struggling with organic fouling without affecting the energy savings offered by those RO systems. Since we're on the topic of one-to-one replacement, it is important to note that elevation RO membranes have some of the industry's highest, or I should say, most forgiving feed water guidelines when it comes to organic parameters like TOC, COD, BOD, and oil and grease. This allows you to design new systems or replace membranes in existing systems with an increased safety margin. While the column on the left shows very typical feed water guidelines that are offered by most conventional RO membrane suppliers, the three columns to the right depict elevated feed water guidelines offered by Elevation RO. Under the optimum performance feed water guidelines, as you can see for Elevation RO, the membranes can handle 5 times more TOC, COD, and BOD than conventional RO membranes, and 25 times more oil and grease in the feed water. Under differentiated performance, feed water guidelines for Elevation RO, you may observe little to no change in the CIP frequency on site, but the existing RO system will then be able to handle much higher concentration of organic load without addition of any, pre-treatment like coagulation or activated carbon. All of this while maintaining the performance of the membrane and its ability to recover after each CIP. Again, these are by no means the absolute feed water limits under which elevation RO membranes can be operated. We have seen much higher feed water characteristics than these, and we encourage you to consult with one of our ZwitterCo application engineering team members if you have feed waters with even higher load of organics. Later in the webinar, we'll take you through a case study that represent each of these columns under ZwitterCo elevation RO membranes. With higher than normal feed water guidelines for organics, clearly we're looking at applications and feed waters where we can offer a very strong value proposition using elevation RO. So how do you decide, if and when you should consider elevation RO? For someone looking at very simple, I should say, quantifiable guidelines, any system that is expected to undergo an alkaline clean or a high pH CIP at least once a month or more, or if you have a system where you're replacing elements within 2 years or less, are definitely good candidates for using elevation RO. If I had to add more color to some of the ideal cases for the use of ZwitterCo RO, here are some of the industries where organic fouling is always a concern. Food and beverage, classic example, chemical processing and refineries, heavy industries like steel mills, automobile, landfill leachate is another very good example. Some indicative feed waters, as you can see over here, where elevation RO membranes can definitely add value, would be wastewater, wastewater coming from landfill leachate, MBR effluent, industrial process waters, high fouling surface waters, all of which, again, very good examples with high concentration of organics. If I had to go deeper and pinpoint on the exposure of some of these organic foulants, that have shown elevation RO outperform conventional RO membranes, I would say, NOM, color, humic acid, which is often found in high fouling surface waters, very general organics like TOC, COD, BOD, or more aggressive foulants like oil and grease are very good organic foulants where we can add value with elevation RO. Now that we have gone through types of industries, feed waters, and foulants, that finds the best use of elevation RO, let us understand how can we get the best out of elevation RO. Most of us have seen this symptoms versus issue chart if you have dealt with RO troubleshooting. In all the cases that are showing water droplets in this slide, which I'm going to click through, there's a good chance you'll see a benefit from ZwitterShield technology. Fewer drops meaning there are some challenges still left to be addressed to unlock the full value of elevation RO. If your main issue, for example, is organic fouling from high TOC and COD, then you're going to see maximum benefit using elevation RO membrane with ZwitterShield technology. If the reduction in normalized permeate flow is due to scaling, you may not see any improvement because this is not a technology designed to stop scaling, and it is not a feasible problem to solve with this membrane chemistry. In case of following due to, for example, sustained exposure to oil and grease, you'll definitely see an improvement, but you still may not get all the way to the start of permeability, for instance. In such cases, we would recommend considering a better pre-treatment, often offered by something like expedition membranes that Chris mentioned earlier. In case of feed to concentrate differential pressure increase, we have seen cases ZwitterShield makes an improvement in the performance recovery, but it is important to note that we need to respect the RO feed limiting conditions. For example, your SDI, your turbidity, your TSS. We need to address the pre-filtration or pre-treatment to have a really successful install. And that's also particularly true if you have an irreversibly high DP climb. With the case of a sudden increase in your normalized permeate conductivity, there's often an operational component to it and needs to be addressed on site. For example, slipped O-rings or slipped brine seals. But if you're noticing a gradual increase in normalized permeate conductivity that's ticking up after each CIP, we can definitely take benefit of elevation RO in extending your membrane life. Let us go through the OpEx savings we can aim for with the use of elevation RO. There are different ways customer can realize value from elevation RO. This could include, reduced CIP frequency and a result, also reduction in chemical use, reduced downtime, and potentially even reduced chemical exposure to the membranes, which can extend your membrane life. We've seen commodity chemicals to be quite effective for CIP and in recovering the performance. And we don't need specialty cleaners at all times for elevation RO. Of course, every system may not be able to realize all these benefits, and it is up to the site to determine what's the most important out of all these benefits to their OpEx profile. Let us go through a use case, for the OpEx savings. There's a site that used conventional RO membranes. They conducted about 24 CIPs per year. If you had to take a guess on how much would be the annual operating cost per element if they used, a specialty cleaner and took about 6 hours of labor and downtime during the CIP, it's a whopping $410. This makes us think how quickly the operating costs can climb or add up when the membranes are exposed to organic fouling. On the flip side, ZwitterCo RO membranes, we were able to reduce the CIP frequency by 50%, which means from 24 CIPs down to 12 CIPs per year. Moreover, the ZwitterCo elevation RO used commodity cleaners and a shorter CIP cycle, which meant an annual operating cost per element drops down to $58 per element, which is an 85% savings over conventional RO membranes. Getting the most out of RO section is always incomplete without going through the do's and don'ts. We strongly recommend consulting with our applications engineering team about the CIP goals, and the suggested changes should be introduced gradually while observing the effects. While our focus is on organic fouling with elevation RO and optimizing the operation around like alkaline CIP, for example, it is also important to pay close attention to other issues like scaling. A must for any site, goes without saying. Do log the operating and analytical data for us to review and optimize the performance. Switching to some of the things that you should take care of or avoid. Please don't use chemicals like chlorine or bleach, as the underlying membrane is still a polyamide membrane. Respect the pH limits, and please consult with us before selecting a detergent or a surfactant. We do not recommend to remove or bypass any existing pre-treatment or make any large process or set point changes without consulting with us. Moving to this last slide of this section of getting the most out of elevation RO, we have fielded this question from quite a few customers in the past. What kind of systems are compatible with elevation RO? And the answer is pretty simple. Any kind of RO system can use elevation RO. Be it your conventional Christmas tree tapered array style RO system, or a closed loop semi-batch kind of RO system, or batch type RO system, or even a feed and bleed style RO system. We want to make it very easy to replace RO memories in an existing system at elevation. And it is meant to be a direct replacement. So most of the basic membrane guidelines will still remain the same. For example, your element loading guidelines. But if you're looking at something more specific, like your minimum maximum feed flow rates per element, we do have a technical manual that we can share with you. I often get asked by customers, do you have a design projections tool so we can project our RO performance, be it in an existing system or a new system? So I'm going to hand it over to Andrew to talk about both, how to approach that and something more exciting coming from our end on that front. Over to you, Andrew.
Thank you, Umang. As Umang said, elevation membranes are designed to be one-for-one replacements in a variety of common RO designs. One of the more common questions we get is whether ZwitterCo has the software to help simulate RO performance. And as Umang also said, I'm happy to share with you that this a special sneak peek of the new tool that we've been developing. So we've been working on this very closely with our team, and over the last year, as well as with a technology partner, to develop a customized software tool for ZwitterCo customers to run performance projections. The model is calibrated with a ton of data for the ZwitterCo elevation elements themselves, and our teams put a lot of work into its accuracy. So next I'm going to switch to the software itself. So we decided to go with a web-based tool to make adoption very easy and seamless. No need to get any admin permissions or anything kind of like that for installation. So on the screen here, you can see you can select the project that we're working on. So all the projects that you have can be loaded up and saved to your account, and of course be private to only you as a user. So then from here, you can pick your project. And this will take you to the next screen, which is your water quality. So that's going to be here. So you can see here, you have the water quality. It includes unit selection for water type. We can also specify all major ions. And if we end up with a charge imbalance like we have here, you can change that by either adding sodium or calcium or other ions to balance. So we'll just do sodium for here. And that cleanly changes the charge balance. So then once you have all these parameters input, we can hit save here. And that's going to take her to our next screen, which is our design details. So we have multiple designs that you can use. This is just one of the designs here. And from here, you can change things like recovery, number of stages. You can even adjust your pressures with interstage boosting, all these different things. And then you can also choose your full catalog of elevation ZwitterCo RO elements. You can import those. And there's also a couple options for more advanced things like concentrate recycle, and that shows up in the diagram down below. So then if we go and press save here again, we'll get an overview. So the calculations will be run, and we'll have a kind of a summary of the projection with things like stream compositions and different little drop-down menus here. So an easier way to do this is just pulling it into a full PDF report. And that is right here. And as you can see, it gives you all your information on the projection that you just ran. You get your water quality, permeate quality, and all these different things. So as I mentioned, we're still in development and it's not available for customers yet. But if you have any designs to run, our applications team has full access to these models, and as well as a bunch of other validation data. So we'd be happy to help you with anything you need. So as you can see, we've been working very hard to bring this much requested capability to our customers later this year. And if you're interested in being among the first users to get access to this, we will be sending out a registration link following this webinar. And I really look forward to hearing from you and working with you on your future RO projects. Next, Chris will come back and take us through some real-world data before we get to our Q&A. Thank you.
Thanks, Andrew. I think what I'd like to do is kind of bring us back to this water quality chart that Umang shared with us before. And there's a lot to unpack here. So I want to try to give a little bit of color behind what we mean by optimum membrane performance or differentiated membrane performance. I think Umang gave us a really nice description of it, but it might be helpful to just kind of see what it looks like in the real world. We're going to start by taking a look at this first column, the optimum membrane performance. So as Umang mentioned, these are quite high values compared to the other membranes available right now. And so they really provide a pretty big differentiation. But what this kind of optimum membrane performance, if you kind of decode that, it means is if your water quality meets these guidelines, you should expect to have a really well-functioning RO system, maybe cleaning a couple times a year and being a pretty stable operation. So a great example of where you might see something like this is in something like a surface water that's got natural organic material. Here we see a situation where elevation RO membranes were used to treat water that fell outside those kind of conventional RO organic guidelines that you would see out in the market. The maximum COD here ran to about 50 milligrams per liter, but it was within that optimum membrane performance criteria that you see in the ZwitterCo elevation guidance. The other membranes used at the site had to clean pretty frequently, as much as once a month, although it did vary through the year. And those membranes only lasted a year or two because of that heavy cleaning burden, and there were some very tight water quality requirements to hit. And so as that chemical damage started to accumulate, those membranes couldn't be used for very long. And so the nice feature of this install was that in addition to the historical data, this was a 2-train system where we got to really see the difference in performance between an elevation membrane using the ZwitterShield technology and a standard, really a gold standard RO from a really major manufacturer, well-respected manufacturer. So very good membranes, but not equipped with the ZwitterShield technology. This is some of the plant operating data. And so there's a couple things to unpack here. You see the ZwitterCo elevation data is in the light blue. And this is a site, like many, where the control system has to maintain a certain flow rate. So unlike the lab data we looked at before, you don't see a flux drop off. What you do see is a change in the normalized permeate flow. And what this means is after we adjust that permeate flow for the operating pressure and the other conditions, sort of how much bang you're getting for your buck out of that membrane. You can see that on average, these elevation RO membranes were operating at a higher normalized flow. And in addition, they were able to do that with a much less frequent CIP cadence. So over the year of data shown here, you have the conventional membranes that need to be CIP'd about 7 times to maintain their performance, whilst the ZwitterCo elevation membranes were able to run in the same environment on the same water, but only needed 2 CIPs during that year. That's really one of the big takeaways here. And as Umang said, different sites have different operational priorities. At this site, reducing the cleaning frequency and running at a higher normalized permeate flow were big value drivers for this end user. If we come back to our chart here and get into the middle column, this differentiated membrane performance, this is where we're going to start looking at more challenging feed waters. This falls, in this category of under 200 COD. To recap, the conventional wisdom for brackish water RO is to keep the COD below about 10 milligrams per liter. So the case we're about to look at is more than 10 times this value, with an average of over 100 and transients even higher. This is where you're going to definitely see a differentiated membrane performance, but because of the challenging feed water quality, cleaning is going to be a more regular part of the operation, and the operations are going to have to be optimized in a way to deal with that extreme challenge. Another, very indicative use case of where you see this is something like a tertiary treatment. So treating, MBR effluent, for example, with a RO membrane to produce maybe boiler water or cooling tower makeup or some other water reuse. This is an example from one of our partners in the UK. And, this is you see this a lot in these kind of industrial MBRs where because the feed water coming into the MBR is variable, the MBR performance can be a little variable, and breakthroughs of high levels of COD are not uncommon. Looking through the water quality, we see an average COD of over 100 milligrams per liter. If you're familiar with RO design and operation, this slide is probably ringing some alarm bells and maybe making your hair stand up right now to try to put an RO in water like this. And the end result, we had a really successful operation. We were actually able to exceed the design parameters for RO recovery, as well as the cleaning frequency and the overall cleaning cost due to the switch to commodity chemicals. And when we say commodity chemicals, what we mean is simple things like acid, base, bleach that you can get for a much lower cost than a formulated cleaner. This site was also able to realize a reduction in the operating pressure relative to the design basis, which was based on conventional membranes. And in addition, saved a lot of energy by running their CAPs at a lower temperature, which saved them a lot on their energy bills. Finally, we have the third column, the talk to us. As Umang mentioned, these are not absolute limits, and we have seen these membranes do some incredible things. I want to preface that by saying it's important to understand that when you're in one of these extreme cases, the membrane operations of the plant are not going to look like they would at the first case that we looked at. These are high value situations where the need to treat the water or the other operational costs associated with it dramatically outweigh the more intense operations, more frequent CIPs. And so that's going to vary case by case. So you're not going to get a easy to predict, there won't be simple answers to things like how often the CIP or how long the membranes will last, because these are necessarily extreme cases. What I wanted to walk through here is an example for a customer that might be curious, just how far can we push it? So this is an example from food processing where we have basically a sugar refinery and the wastewater. Now, this is a combined wastewater with a lot of different sources, including some backwash from some ion exchange resins, and a bunch of other sources that contain everything from oil and protein to sugar. This is a stream that also had a really variable TDS, and so this is a very challenging application for an RO. There was no normal day here. As we look into the water quality, I mean, it's really off the charts. We have nearly 3,000 COD, along with 1,000 BOD, and a variable hardness, protein in the form of TKN. You can see in the operational data, though, one of the hallmarks of these membranes is their ability to recover even from these transients and upsets. And so while day by day there was all sorts of switches from one feed source to another, operational needs meant we had to turn way down or turn back up. And so things were kind of all over the place. But as you can see from the trend line, the performance was stable and we were able to continually recover the membranes. What this looks like for a visual, you can see here the feed water on the left, the permeate in the center, and the concentrate on the right. And these are really extreme fluids to be sending through an RO membrane. And so the ability to run on this kind of feed water and continually recover was crucial for this site. Now, keeping this membrane system operating well did involve a CIP, every 3 or 4 days. And so we don't want to, the point of our water quality guidelines is not to say there's a universal answer, but to help you understand that for the different types of use cases you might use the elevation membranes in, you're going to have a little bit different operational tempo depending on the severity of the water quality challenge. Another example of a sort of extreme water where we've had a lot of success is landfill leachate, and we do a ton of work in landfill leachate. I want to leave time for a Q&A, so we're not going to go into the details here because we do have an entire webinar dedicated to this particular site, and that was a really nice webinar where one of our customers joined us to talk about their experience with the elevation membranes. We have a ton of this on our website, and so if you go to ZwitterCo.com/leachate, you'll land on our leachate landing page. There's videos, there's recordings of webinars, and there's a lot of material. If you're working in this space, we'd love to talk to you because we think it's a really great fit. And so with that, I think myself and the other members of the team will now turn to some of the questions that we've received over the last 30 or 40 minutes from the audience, and we'll answer as many as we can before we run out of time.
Okay, thanks, Chris, and thanks to Andrew and Umang for your insights as well. It's time for a quick Q&A. Feel free to continue submitting questions, and we'll answer as many as we can in the next few minutes. The first question we have is, what is the chemical compatibility for ZwitterShield? Andrew, may you take that?
Great, yeah, I'll take that one. It's a good question. So we do have a full technical manual in review right now, and that goes a lot further into the details on this. But in general, some takeaways is the ZwitterShield itself doesn't actually change the underlying chemical compatibility of your membrane. We're using a polyamide RO. So as Umang said, chlorine's not allowed. The only caveat is my team would want to look at specialty cleaning blends. So on one hand, you might not need them anymore. And that's one of the great benefits of the ZwitterShield. But at a minimum, we'd want to review and make sure that there's no potential for any damage. So we have a number of commercial cleaners that we've already tested and improved, and reach out to us if you have any questions.
All right, thanks, Andrew. Okay, next one. Let's see. Is the technology available for seawater membranes?
I'll take this. It's a really great question. We get it a lot. Our team's really focused right now on the success in the brackish RO space, but we certainly see the opportunity in seawater, in NF, nanofiltration, in UF. So definitely stay in touch. Stay in touch with us, and you'll be the first to hear about new products as they come out.
Great. Okay, another question. How often do ZwitterCo membranes need to be cleaned?
So it's a good one. I can take this one, Christy. So as we went through, I know Umang and Chris went through a little bit too in the webinar. There really is no simple answer for this. It's going to really depend on how challenging the feed water is, and then also other variables like recovery and flux that you're pushing it to, and things like that. And that's where like my team can come in and help help you optimize, your cleanings and operations. So feel free to reach out to us with any specific applications. Thanks.
Thank you. Okay, what is the price of a ZwitterShield membrane compared to a regular RO? Umang,
I was sort of waiting for that question. It's definitely a little bit more expensive than your standard, or I should say conventional RO membrane. But if you go back to that use case that I showed, in the very first year or 1 year alone, you're looking at an OpEx savings of about $350 per element. So we've seen most of our customers find the value, worth the difference or the price difference in the very first year itself. But then the benefit actually extends to the entire membrane life. So I would say about 25 to 30% price difference is easily justified and has been pretty acceptable to the customers that we have worked with so far.
Okay, thank you. Okay, next one. Can the ZwitterShield be applied to existing membranes?
I'll take that. I think the question's asking perhaps about in situ application. Definition of existing membrane is maybe not clear, but let's talk about in situ. So simple answer is no. ZwitterShield is a pretty involved and pretty sophisticated manufacturing process, and that actually happens during the making of the membrane flat sheet, so long before the element is rolled up. And this is essential to make sure that the things I was talking about before, right? It's a permanent barrier. It is now the new top surface of the membrane. It's not something that can be done in a system that's already installed.
Okay, thanks. Okay, let's see. Is the ZwitterShield available for, so this person's asked for a specific manufacturer. So let's just say other brands of membranes. I think that kind of follows the last question.
Sure. That's a really interesting question. I think as you saw in our presentation, we developed the technology to be additive to existing, RO technology. But as of right now, ZwitterCo elevation membrane is the only membrane on the market with ZwitterShield.
Okay, thank you. All right, got a software question. Does the RO software calculate the rate of fouling or CIP?
That's a good one. I don't think anyone's really cracked it yet, but the short answer is no, not yet. We're working on gathering as much data as possible, but it's a tough one to crack. Water chemistry in itself is highly variable to get measurements like COD and TOC, and they're not specific enough for the exact organic material that's in the water. So that being said, my team has a lot of experience in different applications, and we can give you a lot of guidance knowing what application you're in if you reach out to us. So we're definitely looking hard into solving this and getting a better answer there.
Thanks. All right, I think maybe like one more question. So let's go with, do you have any references using this membrane to treat wastewater for breweries?
Yeah, I can take that, Christy. We've you'll not believe in a very short period of time, ever since we have introduced Elevation RO, we've had good traction, and so there's a very strong list of references that we have, including breweries, which we can always share upon request. So feel free to reach out to us, and we can share the references more specific around breweries as well.
Thank you. Okay. Okay, we do have more questions, but I think we're pretty much out of time. So thanks to everybody who engaged with our team and sent in questions during this webinar. And thanks again for attending this first ZwitterCo Elevation webinar. Hope you got some great insights into our technology, ideas about how you can work with the ZwitterCo team in the future. And be sure to check your inbox. We've mentioned that we have this demo software. We've mentioned case studies. We have lots of things we'd love to share with you. And so we'll be sending you an email pretty soon with a link to this webinar as an on-demand, so you can share that with your team, along with more information on demoing the software that Andrew mentioned and information on case studies and our technology. Chris, Umang, Andrew, thank you again so much for sharing your knowledge with everyone. And again, thanks to everyone who's still on this call. Please visit our website, ZwitterCo.com, to learn more about us. And we hope to work with you all soon. Have a great rest of your day. Thanks.